Hello guys, let us now see few examples based on L Hospital's rule. Actually we pronunciate this as L'Hopital's rule. So let us go. Our first question is evaluate limit x tends to 0 x raised to x. If I see x raised to x, it is of the form 0 raised to 0. 0 raised to 0 is an indeterminate form. So what to do? There is no other go. We have to bring x down. For that, we have to take log. So let us just nominate this. Let us call it as y. Y is equal to limit x tends to 0 x raised to x. Then we take log on both sides. It becomes log y equal to limit x tends to 0 log of x raised to x. By the properties of logarithm, this index x comes down as a coefficient. So we are getting this as limit x tends to 0 x log x. Now x is 0 and at 0 log is not defined. So it is of the form 0 into infinity. Now this 0, I mean x, we can get it down so that we can use L'Hopital's rule. So we are taking this x down as upon 1 by x divided by the reciprocal. So limit x tends to 0 log x upon 1 by x. So now we observe this is of the form infinity upon infinity. We have two forms, either 0 by 0 or we call it infinity by infinity. So this is infinity by infinity form. Let us apply L'Hopital's rule. So derivative of the numerator, derivative of log x is 1 upon x that we have written, and that of 1 by x is minus 1 upon x square. This is L'Hopital's rule. What we do is limit of f of x upon g of x is the same as limit of the derivative of f of x upon derivative of g of x. So we have taken here 1 by x upon minus 1 by x square. Now let us simplify this. If I simplify by proper simplification, we get the answer to be minus x, and now you apply limit on it. So it becomes 0. But this is not the limiting value. This is the value of log y. We got log y equal to 0. So we have to take anti-log. So y becomes e raised to 0, and e raised to 0 is 1. E raised to 0 is 1. So the limiting value is 1. Now let us go to second question. This question is again of the same form, but the limit is calculated at 1. Question says evaluate limit x tends to 1 x minus 1 raised to x minus 1. So let us call again this as y. Again we have to take log. So as you are watching, this is again of the form 0 raised to 0. Taking log, this x minus 1 can be brought down as you are watching. Now, this x minus 1 can be brought down as we did in the previous case. Same kind of thing. Yes, you can watch it. This was 0 into infinity form. Again on the same lines we brought it to infinity upon infinity form. Now we applied L'Hopital's rule. Derivative of logarithm is 1 upon, the reciprocal. And derivative of 1 upon x minus 1 becomes minus 1 upon x minus 1 bracket square. Yet we haven't applied limit. We are just applying L'Hopital's rule. So after simplification, this quotient is nothing but minus of x minus 1, and now let us apply limit on it, which becomes 0. Again we have got the value of log y as 0, so we have to apply anti-log, and we got y equal to e raised to 0, meaning thereby 1. So the limiting value is 1. Let us now move to another type of question. Here we are having limit x tends to 0, numerator is e raised to x minus cos x minus x, denominator is x sin x. What we observe here, if I put the value of x as a 0, e raised to 0 is 1, cos of 0 is 1. So what we observe, 1 minus 1 becomes a 0 and minus 0. The numerator is completely 0. Denominator is obviously 0. So 0 by 0 form. So let us apply L'Hopital's rule. What we need to do is differentiate the numerator separately, differentiate the denominator separately. So you can see e raised to x has derivative e raised to x. Cos x has derivative minus sin x, so it becomes e raised to x plus sin x minus derivative of x is 1. In the denominator, we applied product rule. X as it is, derivative of sin x is cos x, plus derivative of x is 1, sin x as it is. So this was L'Hopital's rule we applied. Now let us see what format we have reached to. Again I put x equal to 0, e raised to 0 is 1, plus sin 0 is 0, minus 1. So 1 minus 1 makes it 0. Denominator, it is x into cos x, so obviously multiplication by 0 makes it 0, and sin 0 is a 0. So again we are at 0 by 0 format. So let us apply L'Hopital's rule once again. Derivative of e raised to x is e raised to x. That of sin x is cos x. In the denominator we applied product rule. So x as it is into derivative of cos x is minus sin x. So the term becomes minus x sin x. Plus derivative of x is 1, cos x as it is. And now there is one more term with us, that is sin x. Its derivative is cos x. Now let us see what format we have reached. If I put x equal to 0, I am 0 free now. So let us put x equal to 0. So e raised to 0 is 1, cos of 0 is 1, denominator x is 0, so first term will be 0, cos of 0 is 1. So we got 1 plus 1 upon 1 plus 1, meaning thereby answer is 1. So the limiting value is 1. The L'Hopital's rule has made calculation of limits very easy. Now let us move to another pattern. So what we are reaching to is limit x tends to 0, 1 by x minus 1 upon e raised to x minus 1. If I put x equal to 0, the first term becomes infinity, minus second term you observe e raised to 0 is 1. So again there is 0 in the denominator, means we are reaching to infinity minus infinity form. So basically we have first to solve the subtraction. So the denominator will be the LCM of the denominators. So x times e raised to x minus 1. So obviously the numerator will be e raised to x minus 1 minus x. Now let us see what format we have reached to. If I put x equal to 0, e raised to 0 is 1, 1 minus 1 I got a 0, minus a 0. And the denominator is multiplication by x, so obviously it is 0. 0 by 0 form we are reaching to. So by L'Hopital's rule we will differentiate the numerator. Derivative of e raised to x is e raised to x. That of minus 1 is a 0. And minus x has derivative minus 1. In the denominator we applied product rule. X as it is. Derivative of the bracket is e raised to x. Plus bracket as it is, derivative of x is 1. Now which form we have reached to? If I put x equal to 0, e raised to 0 is 1. So again I observe there is 0 in the numerator, at the same time 0 in the denominator. So it's a 0 by 0 form. Let us once again apply L'Hopital's rule. Derivative of the numerator will be e raised to x only. In the denominator again I have to apply the product formula and e raised to x. And now I think we are 0 free. If I put x equal to 0, what do I get? E raised to 0 is 1. Denominator, first term 0, second term 1, third term 1. So I got the answer to be half. Thus, the limiting value is half. Let us move to one more question. Here our limit is applied at pi by 2 and trigonometric functions we are handling. Limit x tends to pi by 2 sec x minus tan x. We know sec x is 1 upon cos x, tan x is sin x upon cos x, and cos is 0 at pi by 2. So very obviously this is infinity minus infinity form. So we have written it separately. Now we want to subtract, so better let us first complete subtraction. So common denominator is cos x, numerator will be 1 minus sin x. Now let us see what happens. If I put x equal to pi by 2, cos pi by 2 is 0, so 0 in the denominator. Sin pi by 2 is 1, so 1 minus 1 makes it 0 in the numerator. So again we are reaching to 0 by 0 form. So let us go with L'Hopital's rule. Derivative of numerator will be minus sign as it is. Derivative of sin is cos. In the denominator, derivative of cos is minus sin x. And now let us see, have we come out of that zeros? So cos 90 is 1. Sorry, 0 and sin 90 is 1. So we are getting 0 by 1, which is 0. So the answer is 0. So this way we use L'Hopital's rule to calculate the indeterminate forms, which is quite easy then.